Hello everyone, how are you today? Abulfazl here with another video, but this time it is not a tutorial one. I was thinking about topic of the next video, and I thought that we can finish the finite difference technique method. But before that, I decided to make another video. That's why I make this one and made a poll to know your opinion. In the previous videos, using the finite difference method, we solved some simple partial differential equation like heat transfer equation, wave equation, Laplace equation. They was rather simple, and we saw that it's possible to find both analytical and numerical solution. But in some complicated problem, it's hard to find the analytical solution, and that's why we use the numerical methods. So I want to make another video. It's like a little workshop, and I'm going to solve some complicated partial differential equation that are entangled to each other. And I'm interested to know your feedback about this video. So if you are interested to such a small workshop, please let me know in this link. I made the poll here, and let me show you what I mean by the complicated system of equation. Okay, this is the system of equation that we are going to solve in our workshop. The first equation is Poisson equation, as you see here. And in this equation, phi is represent the potential, and I and sub I represent the density of ions, and sub E represent the density of electron. And we know that if we multiply the density of charges to the elementary charge, we will have the charge density. Right, and epsilon 0 here is the permittivity of the vacuum. And if we assume that the density of electron can be expressed by the Boltzmann equation, as you see here, and you see that the density of electron is related to the potential through such exponential function. So if we substitute this NE from here to here, what we have, this is a nonlinear equation, and solving of a nonlinear equation is not too easy, and we need some trick. In the workshop you will learn how you can solve it, and if we assume that the density of ions can be derived from this continuity equation, right, and the continuity equation indeed connected to the velocity of the ions in a different direction, because this is the vector here, vector velocity. And moreover, the velocity of the ions also connected to the potential, to this potential through the momentum transfer equation. This one, as you see here, again, this is the vector. We wrote it with the capital V sub I, and this sub I represents a different direction of velocity. It could be in 3 dimension. But we will solve it in 2 dimensions. So if we simplify this continuity equation and the momentum transfer equation in the Cartesian coordinate and consider 2-dimensional problem, we will reach to such a system of equation that you'll see here. This one is a Poisson equation, and we substitute this Boltzmann equation here. And we will only consider 2 components, x direction and the y direction. And this is the momentum transfer equation. This is the I component of the momentum transfer equation, and it will be the j component or y component of the momentum transfer equation. I think solving of this problem can give you a good vision and a good understanding of the using of a finite difference technique. So if you are interested, and if most of you agree with this little workshop, the next video will be devoted to solving of such a system of equation. And if this is the first time that you are visiting my channel, please don't forget to like the video and subscribe my channel. You can find a lot of useful information about the numerical method and the physical problem in my channel. Thank you very much, and see you at the next video. Sorry guys, I checked my YouTube studio and I can't add the poll here, because when I push the adding cards here, there's no option for poll, and there's only video playlist channel Sorry for that. So please let me know your feedback in the comments. Thank you so much.